So, functions of the respiratory system. The big one is gas exchange. Get oxygen into our bodies, get the carbon dioxide out. It also produces the voice for communication and regulates blood pH. There's 4 major processes going on in movement of oxygen and carbon dioxide. Ventilation is just moving the air in and out. It's a fancy word for breathing. External respiration is gas exchange between the lungs and the blood. So this is happening in the respiratory system, in the pulmonary circuit of circulation. You're exchanging gases between your blood and the air, basically. Internal respiration is at the other end in the systemic circuit, exchanging the gases between the blood and the tissues. And then cellular respiration, if you remember that from chapter 4 and brief mentions in chapter 18, that is how we get energy from our food, which requires oxygen and creates carbon dioxide. Okay, so cellular respiration is the reason we need to do these other 3. Now, the respiratory effects on blood pH, we're going to go into in more detail in chapter 21. And at the end of this chapter, we're going to look at how pH is altered here. So, the cellular respiration produces the CO2. The CO2 can lower your blood pH. How it does that is part of the way it's transported, which is the last thing we look at in this chapter. The respiratory system can change how much CO2 is excreted. The more you get rid of, the less acid it's creating in your body, so your pH goes up. The more you hold on to, it's there to make the acid, the pH goes down. Organs of the respiratory system are classified as upper and lower respiratory tracts. Upper is mainly in your head. It includes the pharynx, which is partially in the neck. And this is where part of the pathway is shared with the digestive system. The lower respiratory tract is exclusively for air, and it's found in the neck and thoracic cavity. And this includes your gas exchange areas. The upper respiratory tract is only moving the air. It's not doing any gas exchange. So let's see which parts you already know. These are pretty obvious. Lungs. You know what the tubes in the lungs are? Bronchi, and then there are also bronchioles. This tube we call your windpipe. Trachea. Voice box. Larynx. Throat. Pharynx. Up here. Nasal cavity. And also shown are a couple of holes here, sinuses. The upper respiratory tract is the nose, nasal cavity, sinuses, and pharynx. Nose refers to the outer structures. Nostrils are the openings for air. Sometimes you'll see them called nares. But our book just goes with nostrils. The outer structure is supported by a little bit of bone up at the top, and then mostly cartilage, and there's some muscle attached, like when you flare out your nostrils, there's muscles involved there. Nose hairs are for catching large particles in the air. Inside the nasal cavity, you've got the septum that divides it into 2. And like the outer nose, it's a little bit bone and then mostly cartilage. Nasal concave, we saw on the picture, those ridges on the side. They're basically little scroll-shaped bones that stick out from the outer wall of the nasal cavity and increase the surface area that the air is going past. The lining is a mucous membrane. In the outer portion of your nostrils where you can reach and it has to deal with friction, there's stratified squamous, but most of it that doesn't get poked with anything large is pseudostratified epithelium. That's the kind that has cilia and goblet cells to produce mucus, and then the cilia moves the mucus to the pharynx where you can swallow it. Makes room for clean mucus. The reason for the increased surface area. All of the airways obviously have the job of conducting the air from outside to the gas exchange areas of your lungs. But they have 3 additional functions. One of those is to warm the air to body temperature, because what's right in the middle between your lungs? Heart. Your heart's going to pump the blood everywhere, and if your lungs have cold air in them, then it's going to cool your heart too, and all of your blood. Moisten the air. If it's too dry, then the delicate tissues inside the lung can dry out and be damaged more easily. And trap small particles like dust and bacteria. So the more surface area the air has to pass by getting to the gas exchange areas, the more it contacts the epithelium where mucus can trap the particles. The water of the mucus can evaporate into the air if necessary, and the capillaries in the walls have heat in the blood to heat up that air as it comes down. And this is why when you exhale, it's warm, and why you can see your breath when it's cold is that moisture that you've put into the air condensing when it hits the cold. We will also see an increase in surface area inside the lungs in the bronchial tree, which is all those tubes. Sinuses are chambers in the skull, gaps inside the bone that are filled with air and lined with a mucous membrane. They have small connections to the nasal cavity. The sinuses are named for which bone they're in. Frontal, ethmoid, which is kind of in between the nose and eyes, maxillary, and sphenoid, which is actually back behind the nasopharynx, but has a small connection to the other mucous membranes. So the sinuses reduce the weight of the skull by filling some of the space with air instead of bone, and the air in them resonates to make your voice louder. This illustrates locations of the sinuses from the front and the side. You can recognize the frontal and sphenoid sinuses that we learned in AP1 when we did the skull. Maxillary, here in your cheeks. Ethmoid there's a little hard to point to because they're kind of back in there. There's gaps in the bone itself, both down here and up in the top where it connects to the brain. Questions on sinuses? Pharynx, we already covered in the digestive chapter. Starting about here where it goes narrow, we get to, what's the first part? Nasopharynx. What kind of tonsil is in it? Pharyngeal, also known as adenoids. From the tip of the uvula to the epiglottis is what portion? Oropharynx. We have a tonsil at the back of the tongue. What's the word for tongue? Hint, the word for types of speaking comes from the word for tongues. Lingual. So that's a lingual tonsil. And then these that are on the side are the palatine tonsils. Okay. The ones most often just called tonsils.
Now, whatever they do, when they remove tonsils, do they remove all those? Or do they just
I'm not
remove the
sure
one
about lingual. Usually, they're most likely to remove just the adenoids. If they say tonsils, they definitely mean palatine. I'm not sure about lingual. And after the epiglottis, you're in what portion? Laryngopharynx, which actually comes to here. This piece of cartilage that's the lowest portion of the larynx lines up with the end of the pharynx and beginning of the esophagus. The lower respiratory tract, we've got the larynx, trachea, bronchial tree, and lungs. The larynx is the first area that's just for air. It has several structures to prevent entry of foreign objects into the lower portions, and it's the part that produces the voice and the cough. There are three major pieces of cartilage that make up the larynx. From the front, they look like this. You've got the thyroid cartilage, cricoid. After that is the trachea. They're held together by ligaments. There's also ligaments that go up from the thyroid cartilage and connect to, anybody remember the name of the bone that's in your larynx? Yeah. And if you had just the larynx to look at, none of the other soft tissues, you would see a little bit of the epiglottis showing above the hyoid ring. So those are your three main pieces of cartilage. Thyroid means resembling a shield. The thyroid gland is actually a little bit lower. It's mostly in front of the trachea rather than the larynx, but they are roughly similar in shape. This is the one that forms the Adam's apple in men. The reason for that is testosterone stimulates cartilage growth more than estrogen does, and so males in puberty, the larynx grows more. Thyroid cartilage also protects the larynx from the anterior. The cricoid cartilage is a complete ring, and it holds the vocal apparatus, the structures that make your voice. If we look from the side, the thyroid cartilage has some spikes in the back and then an open area. The cricoid is shorter in front, taller in back. I'll just put in these ligaments. And then you have the hyoid again and see some epiglottis. And if we take a sagittal cut, you just see a little bit of the thyroid cartilage in the front, two sections of cricoid, and then the epiglottis would go something like this. And then in here is where we would have the vocal structures as well. The epiglottis is a flap that comes down to block the larynx when you swallow. Thyroid and cricoid cartilage are hyaline, which is what makes up most of your nose. So if you feel that, that's about how tough they are. The epiglottis is elastic cartilage, like in your ears. It's more flexible, and that allows it to bend a bit to cover the opening when you swallow and it's pulled down. Questions on the cartilages? The vocal apparatus is made up of two sets of folds in the walls of the larynx. The top ones are softer and muscular. They're sometimes called false vocal cords because they're not the ones that vibrate and make sound. What they are is another layer of protection to keep things from getting down into the deeper airways when you swallow. The true vocal cords are below the